So how many people have been to the Bailey-Mathews National Shell Museum, which is on Sanibel, by the way? Okay, a couple. And how many have heard of it but have not been there? Okay. So a very, very quick synopsis of what the museum is. It's a natural history museum and aquarium that opened in 1995, and it opened after about 10 years of work by volunteers on Sanibel. So I having lived in Sanibel for 2 years and been coming here for 15, I feel like there's a kind of a kinship between a place like Minnesota Key and Sanibel, with a very, very strong conservation ethic and a commitment to keeping things a certain way. And one of those major pillars in Sanibel, of course, is shells and shelling. It having the reputation as one of the major destinations in the U.S. And the reason for that is, I mean, all of Southwest Florida has really terrific shells, thanks to the Gulf of Mexico and lots of other factors. But two things make Sanibel a place where a lot more shells wash up than maybe some other places. One is something is the continental shelf of the Gulf of Mexico stays very shallow for a very long period of long distance. So going out 70, 80 miles, it's roughly 10 feet deep in a lot of places. So that allows a lot of makes it possible for mollusks. Mollusks are the animals from which shells come. Maybe not everybody knows that. I will admit I didn't necessarily know that when I started interviewing for this job, but it's true. Makes it easy for them to roll in. The other thing is Sanibel is east-west oriented, unlike most barrier islands. So the conditions for that make it more conducive to sort of catching all those shells. So Sanibel, of course, is the big shell place, a very, very active shell club, very active volunteer and shell community who in the early 80s had the idea that it would be an appropriate place for there to be a shell museum, a natural history museum that was focused around shells and mollusks, the animals that make shells. And so they started working on it, and it fits and starts. It took time. Most of them were seasonal. It was a volunteer project, so there weren't paid staff, and the work of assembling collections. And over a period of about 10 years, they sort of moved along, and then it got supercharged in the early to mid 90s by the involvement of a gentleman named Tucker Abbott, who was, like Josa is, a malacologist, but also a great popularizer of shells and shelling as a hobby. He wrote a couple dozen books that sold very well in the 70s and 80s, and really helped bring it to a much wider audience. And a good friend of Tucker's, the actor Raymond Burr of Perry Mason fame. So Raymond Burr was really into shells. He owned an island, South Pacific. Yep. So I'm going to get out, standing in front of Josa. Owned an island in the South Pacific. Good friends with Tucker Abbott, traveled the world to go shelling, and Tucker got him involved, and by lending his celebrity and his marketing savvy to the effort, raised a lot of attention and money for this fledgling effort to build a shell museum, which was ultimately successful, and the place opened in 1995 as approximately a 15,000 square foot, 3-story natural history museum. Josa enters the scene just a year later in 1996. Ever since, he's been the curator of the collection. For 17 of those years, he served as executive director of the museum, and he spearheaded the amassing of a collection of about 550,000 shells, which is what the museum has today. And do we exhibit that many? No, not even close. Our permanent exhibit hall, which is about 35 different kinds of exhibits related to shells. Maybe it's shells from around the world, or maybe it's how shells are important in currency, such as cowries, which were an important kind of currency in African and Asian nations. Shells in art and architecture. Also how mollusks relate to important regional coastal ecosystems here, such as mangroves. and estuaries, water quality. So those are the kinds of things that the exhibits are talking about, but only, probably something like 1,000, 1,500 shells are on view in these exhibits. The real, why do we have over 500,000 specimens? The real value of a natural history collection, whether it's shells or whatever it may be, is in the data that accompanies it. So when people give us collections, they're also telling us what it is, but they're also telling us where it was collected and when. And what people like Josa at museum collections and university collections do is, over time, they enter all of this data into big, online data aggregators and crunchers, and what comes out of it is a huge resource of information on species distribution and biodiversity over a period of time, maybe as much as a couple hundred years, depending on how good the data is. And that becomes very important for researchers of many different kinds of stripes. And so that's the fundamental reason natural history collections, if you're familiar with them at other museums, are so large, running into the many millions of specimens, is because they're first and foremost, they're important as a record in natural history of life on Earth, and then they come to be housed in museums or universities, and we're able to use some of it to create public exhibits. So over the years, Josa helped build this collection with a lot of course, donations from collectors. That's the main source. Sometimes other institutions are looking to shed their mollusk collections, and the Shell Museum is a natural place. But for a small museum, which right before the storm, we're probably about as large an organization as the museum has been, but still small. 20 staff, about a $2 million budget, about 50, 60,000 visitors a year. What was my point, Josa? What was I talking about? But that's the point of which we were before the storm. And then, of course, Hurricane Ian comes along, right? And the impact to us on Sanibel was of course, major. The island had anywhere from, maybe at the low end, 6 feet of flooding to at the high end 18 feet of flooding, and it's amazing. It really was quite a lot of difference over relatively short distances. Captiva Island, which is just to the north, maxed out at about 3 feet of flooding, and still there's plenty of damage there. It's not to minimize what's happening in Captiva, but in the case of the museum, this 3-story structure, we took on almost 6 feet of flooding on the ground level, which was where all the aquariums were housed. So in addition to our shell exhibits I mentioned, our aquariums exhibited about 60 different species of marine life, about 350 animals. Most of them are mollusks, not all, but it included a couple different species of octopus, including a giant Pacific octopus, cuttlefish, giant clams, and then lots of local mollusks, including highly prized ones like Junonia, but then more common ones, lightning whelk, banded tulip, and the like. But that whole level was flooded. We lost about 80% of our marine life. We lost just about all of the equipment that makes the aquariums run, the pumps, the filters, that kind of back-of-house equipment. And then sort of to add a little bit of insult to injury, although we had just replaced the museum's roof this past summer with a brand new metal roof, there were a couple tornadoes that came across, and a 20-foot hole was torn in the roof, which brought in a lot of water from the top. Not so much from the storm, but for folks who were around at the time. It was about 10 days maybe after the storm. We had a couple days of real hard rains. And so that brought in a lot more water.
This is an ideal place for people in Florida and around from Europe who love the sun and the real heat of the summer. And we have air conditioning, of course, in the rooms, and we have TV, and we have all the amenities that have been added through the years. And so but the beach is just the same. And the clear water in the summer is unbelievable. We have a ledge which is out in front of, and you can see it in the clear weather and water, and it's glassy calm, and boats go by, and it is, but the beach is practically empty. It's your place. And at night, when the lights are on, you walk home and you can, underneath the oak trees, you can look up and see the sky and the stars. But around you, surrounding you, is all the greenery and the oaks and the planting, which is natural to Florida. This is a treasure which many people have never seen.
So we had water and structural damage on all three levels, and where we are today is like a lot of people contending either with their homes or their businesses. We're sort of right in between, quote, mitigation, this word that we're all saying so much more than we ever did before, but the ripping out of all the water damage and moldy walls and ceilings, drying out, disinfecting, anti-mold treatments, and beginning to rebuild, which is something we expect will begin in a couple of months, take the better part of a year. And what we'll see in coming back is, in some cases, a restoration of what was there. Our aquariums, which were relatively new, very successful as both an educational aspect of the museum and also a way to bring in new visitors and appeal to multi-generational audiences. We'll look to restore those more or less as they were. Our permanent hall of shell exhibits is one that we had been looking before the storm, but making some updates to from a design point of view, and we'll be pursuing that. We'll also be looking to modify some of its educational content to start saying a lot more about regional environmental and ecological issues, including the kinds of conditions that are producing increasingly threatening storms, and the kinds of regional ecosystem buffers that there are to that, such as mangroves, like I mentioned before. So we see it as a place where we're chiefly a museum where our audience are people who are visiting the area, who are vacationing to the area, and it's a place where we can do a lot of teaching on some subjects that are familiar to those of us who live here or spend a lot of time here, but maybe less so to people who are first-time visitors to the area. What else? Does anyone have any questions? Yeah.
Did the marine life you lost have any ability to survive once they got tossed out?
The question was, the marine life that we lost, did they have any ability to survive? So the answer is some did. Most of the animals that survived were local mollusks, right? Because they've been through, at least from an evolutionary point of view, they've been through stuff like this before. And those animals we released to local water. Of course, we did right after the storm. It was 4 days after the storm that a small group of us were able to get to the museum to attempt an animal rescue. So the quality of the water we were putting them into, we don't know, but we were able to do that. The cold water animals, which included the octopus species, they did not survive because our generator was knocked out very quickly during the storm and unable to keep the water cold in there. But there were some animals, namely some flamboyant cuttlefish. For folks who haven't seen flamboyant cuttlefish, they are amazing, amazing amounts, beautiful, very colorful, from the South Pacific, do well in big groups. They sort of change color and sort of display emotion in the same way that octopuses do. Somehow they survived, a group of 6 of them, and we have friends at the Florida Aquarium in Tampa when we were able to get over there and try to make a rescue, we were able to rescue them and got back to shore, and they took them up to the Florida Aquarium where they're doing okay. But yeah, that's kind of the story there. Yeah. The question was, are Junonias, did they survive? So for folks who, does everyone know what a Junonia is? Or no? Okay. Junonia are, at least in Sanibel, right? Okay. They are among the most prized, if not the most prized, shell. And it's a beautiful, beautiful shell, a Gulf of Mexico species that tends to be quite rare to find, because even though I talked about that very long, shallow continental shelf, where they like to hang out is in the deep water way out there. So it's not all that often that they sort of get up and all the way in. Okay, all right, and then I'll introduce Jose. Thank you. So we had live Junonia in the aquariums. I think maybe the only aquarium / museum that had them, and they're a big attraction. They survived initially. So when we got there on October 4th, they were among the animals that were still alive, and we did not transfer them to another aquarium, but took them in-house, and a couple days later they died. So it was, we assumed it was an absence of their favorite food, which is leaded olives. That was the reason. So, okay, enough of my yakking. Sorry, Buffy. All right, so now it's my pleasure to introduce Jose, and Larry also gave him a terrific introduction, but also say he's a great colleague and a great friend. He has worked and researched in South America and Paris and Miami and Sanibel, and here he is, the soul of the Bailey-Mathews Natural Shell Museum, Jose Leal.
Thank you so much, Sam. And I want to thank Larry and Buffy for the invitation, and you all for being here today. Sam already mentioned some very key points on the things we do at the museum, and the fact that mollusks are such a widespread group and present in all environments on Earth. You go to the highest mountain, the Himalayas. You go down to the oceanic trenches, cold water streams in the Pacific Northwest. You'll find mollusks. There are about 80,000 named species, more or less, and probably many, many more, probably twice as many yet to be discovered. So, and mollusks are, as Sam properly mentioned, they're the bread and butter of the Bailey-Mathews National Shell Museum. We wouldn't be there without mollusks. So, right up a couple of days after the hurricane hit, I said, well, let me look into what could happen to mollusks in the very areas where the hurricane did most damage. Just in theoretical terms, what could happen? And then I will present a little about that, the theory behind the damage done by hurricanes on mollusks, and then at the end give a couple examples of what actually happened. So I want to make clear that the beginning of this talk is not about drawing from any hardcore scientific conclusions, just from the basic knowledge of the environment and what mollusks do for a living. Mollusks are super diverse. We have predators such as the big horse conch there and the lightning whelk on the back. We have herbivores like the queen conch. Later I'll bring the shells around and you can see them. The bivalves, clams, mussels, and oysters, they are filter feeders, so they pump water in, and using their gills, they will retain the food particles they need to make a living, which are, in that case, are microalgae. So all those different constraints on the life of mollusks will place them in better or worse situations in relation to a big storm. So on top of that, I also want to say that there are several studies done on the effects of hurricanes on large mammals, on fish, on sharks, for instance. There are University of Miami, where I acquired my PhD many, many moons ago. They have a very strong shark research group, and they had tagged sharks. And they observed that after Hurricane Irma, a number of the sharks disappeared from the bay, in Biscayne Bay, that is, in Miami, and totally disappeared. They were marked with radio transmitters, and they could see them going offshore. They can detect the arrival of a hurricane a couple of days before the hurricane actually hits because of the changes in pressure. Excuse me. Great triggerfish, which is also a common fish on the Western Atlantic. Same type of study showing that they can detect, the approach of a storm and just get the heck out of Dodge, so to speak. But with our animals, with our little mollusks, that can happen. Either they don't have the ability to detect the arrival of a storm, and if they had, they probably wouldn't have the means to, move. They don't have the locomotion capabilities that fish and dolphins and all that have. So when the storm hits, they're there. So they're not fast enough. Let's look a little about some of the physical effects of a hurricane, depending on where you are. I mean, if you are like us, on Sanibel, Captiva, and Fort Myers Beach, we're on the southern branch of the hurricane when the hurricane hit. So what happened? Well, the most damage was done by storm surge, not by wind. If you're on the northern branch, you have the worst winds coming through. We have, in some areas, you may have strong currents washing the shore. You may have intrusion of rainwater. All those factors will affect marine life in different ways. We have a lot of sand shifting. A good example is what happened to the Sanibel Causeway, where we had at least 4 spots, right, that were where the causeway collapsed and the water was, passing freely. We have a lot of sediments also that come in the water, and the sediments, like fine silt or fine mud, will prevent the bivalves from filter feeding, because instead of filter feeding microalgae, they'll be filter feeding mud, and that's not good for their health. And last but not least, all that sediment, all that sand and mud that's moving will bury mollusks in a way that they normally are not buried. And once buried, they cannot come back to the surface of the sand underwater. Good example are those big guys here, like a queen conch. That's the species that they did the study in the Florida Keys. The queen conchs do not bury, they live on the sand surface. So if a storm pushes a lot of sand on top of them, they're buried for life. They'll be entombed for life. And same thing with potentially can happen to a horse conch or a lightning whelk. Lightning whelk is a very interesting species that we have here, and produces those egg capsules that look like a dried snake skin. You all know about that. And last but not least, a good example of a burying bivalve is a pen shell. And pen shells live at a very, very well established, well determined depth in the sand. So they bury about 2/3 of it, the shell is buried this way, and this upper third here sticks out of the sand. So they can do their filter feeding, they can be pumping water and doing their life business. So once the sand goes on top of them, they're gone. So those are some of the possible effects on some of the sand bottom living mollusks. So we also have species that live way, way high above the high tide line. We have periwinkles. Mangrove periwinkles are snails about yay big, 1.5 inches long at most. And their preferred mode of living is living on red mangrove, living red mangrove. And that area, for instance, in our region where we had storm surges in some points that were about 15 feet above sea level, those trees were completely submerged during the storm surge. And those periwinkles probably left. We still have to go back and look. And one of my plans is going back to some of the mangroves near the Sunnyvale Causeway to do a check on the life of the local periwinkles. The oyster reefs also probably suffered because oysters, they are cemented to their own reef. They grow on top of each other. They form those big clumps. We have lots of oysters here in the back, in the bay here, and also they can also be completely clogged. I think the word is clogged with sediments, with sand and mud. So that's another problem. I mentioned the bivalves and filter feeders, and I showed you a pen shell. We could have the opposite of the mollusks being buried by sand, which the opposite would be sand being removed from that area and just fed out, removing those pen shells, those clams, and that will be left without a home once the sand goes away. I mentioned the periwinkles. There are several species of periwinkles in this area. The mangrove periwinkles living above the high tide line. They love living red mangroves. We have the cloudy periwinkle that lives on dead wood, and basically they only like dead wood. And then we have the placid periwinkle that lives on hard substrates, rocks or human-made structures like bridge pilings and so on. And those were also affected for sure. I was speaking earlier with someone here about the fact that the populations of the queencock in the Keys, they have been monitored by the Florida Fish and Wildlife Conservation Commission. They do surveys every year basically between Key Largo and the Marquesas Keys, which sit just west of Key West. And they found that in that area, the effect of Hurricane Irma was much worse on the populations of queencocks. Hurricane Irma wiped out about 50% of the queencocks in the Keys. And Hurricane Ian, because it had a different path, didn't affect them as much. So those are some real data that are out there following Hurricane Ian. I'm sorry. Shelling can be good. As a matter of fact, I saw a lot of the social media just before Hurricane Ian where people were saying, hey, shelling will be great. And I'm thinking, oh my God. They don't know what they're getting into. Yes, there will be some shelling for sure, but I think that's not what people should be thinking when a hurricane like that, is trying to make landfall near your house. The museum has engaged this past weekend on a shell count, a living mollusk count on Sunnyvale. It's a replica of the similar event done last year by the Sunnyvale Captiva Shell Club. This time the effort was led by workers from the Shell Museum in conjunction with the Sunnyvale Captiva Conservation Foundation to gather some information and basically compare the data that they acquired this year with the findings from last year. The word out is that, there are lots of young mollusks thriving on the beach right now, right? And so the panorama is not that bad for mollusks. I wish it were that way for people, for us who suffer damage and all that. I also had a chance to go out a couple of Mondays, 2 weeks ago, 2 Mondays ago, on the bay with one of the local captains, Captain Brian Holloway, who is a great guy, and he leads tours. And I went. He took me to see some of Cayo Costa and North Captiva and northern Pine Island, and we saw a lot of living mollusks, including big living horse squonks and lightning whelks. And we saw lightning whelks mating, which is a good thing because that's the next generation being prepared. We saw horse conchs feeding, so life was kind of normal for those guys. So that's what we will keep hoping for, is that the things go back to normal. First for mollusks and then for everyone else. So that's my spiel. I don't know if you have any questions.
Can you talk about the birthing process? How do they mate and how do babies come?
Well,
Repeat the question.
yeah, they do mate. That's a very good question, and I can go on and on talk with you for 13 hours here about that. But the thing is, a lot of mollusks, like if you pick the big guys here, the big league, the big predators like a horse conch, or the lightning whelk, which is just behind it, or even the queen conch, which is a herbivore, by the way, they mate, and just like vertebrates, just like people. Some other animals, they have a life that are attached to the substrate, like oysters, or even some of the bivalves that burrow in the sand. They don't do that. They do what we call external fertilization. So the female releases eggs in the water, and the male releases sperm. And just by happenstance, the eggs will be fertilized by, some eggs will be fertilized by some sperm. Not all of them, there's a lot of loss there. And eventually when it fertilizes, an egg is fertilized, it develops and becomes a little larvae that will kind of drift in the water, very happy. And as it grows, at some point will fall to the bottom after a period of time and then begin a new cycle. The other ones, the horse conch and lightning whelk and the queen conch, they mate physically, they get together, and at some point the female will lay their eggs inside of egg capsules, and the egg capsules are protective, so the egg capsules make sure the environment doesn't harm the little guys inside. So it provides nourishment because there's a liquid that's their food, and it provides physical protection against the environment, against predators and all that.
How old is that queen conch about?
Oh, that's a very good question. If you asked me that question about 2 years ago, I wouldn't be able to answer you. But a colleague of ours, Dr. Greg Herbert from USF in Tampa, just published last year a very good paper in which they've done studies, analysis that show that the largest horse conch we know, which sits in the museum, the shell, lived about 16 years. So despite their very large size, they don't have a very long life, and they grow really fast. So a guy like that, probably anywhere between 13 and 15 years of age. We still have to do the same kind of study for the lightning whelks. Any other questions?
Can I say one thing?
About sometimes you find on the ground in the bay those gelatinous masses that looks like jello on the bottom. Are those feeding apparatus or are those egg cases?
The jelly-like translucent.
On the bottom, yeah.
Yeah, I don't know. I have to see a picture to be able to, because there are several things that could look like that. There are some fish that lay their eggs inside those gelatinous masses, almost like frog eggs, but there are no frogs in seawater. So.
Then I had one other question about, since we're all sort of feeling a red tide, are they able to filter out the red tide in the water?
Good question. In most cases, no. The first ones to go are the higher vertebrates, as you well know, manatees, turtles, large fish like the Goliath grouper. When we had the super bad red tide in 2018 in Southwest Florida on Sanibel, we had a lot of big groupers popping up on the causeway. The mollusks, up to a point, they can filter that out, but when it's too much, they begin dying too. Yeah. You had a question at the back? I didn't hear.
How do you determine the age of the conch?
Well, the age of the conch is done using a type of analysis that takes little pieces of shell, all through the spire of the shell. The older shell is, we know the older shell is on top here. And this was the most recently laid part of the shell because they grow in a spiral fashion. So if you take little pieces and look at some types of chemicals, especially oxygen, what we call oxygen isotopes, and compare the different proportions, between the top and the bottom, you're able to gauge the age. It's it's a little complicated. Yes.
Can you speak to the negative effects of shelling as a hobby and as an industry on ecosystems and on populations?
You're talking about shelling dead shells or live shells? Well, it depends.
Shells are room for other animals.
Yeah, I mean, the number of, first of all, let's talk about dead shells. I hear a lot of people talking about, oh, we shouldn't pick up a shell because some hermit crab could use it. True, but there, in my humble opinion as a professional, there are so many more dead shells than there are hermit crabs looking for shells. And if you look at the size, and Sam mentioned something that's pretty key here, is the width of the continental shelf of Florida into the Gulf of Mexico. There are parts of the Gulf of Mexico in which, parts of Florida in which the continental shelf, which is the submerged part of Florida, is about as wide as Florida itself. So Florida is actually twice as wide as we know it because half of it is underwater. And all that is loaded, it's very shallow and it's loaded with living mollusks. And those shells are always washing on the shore. So I think the impact of having a child or having yourself picking up a dead shell and taking home doesn't exist. Now, as to the living ones, it's another controversial situation because you don't want to. There are ethics involved, and I hear the same people who go fishing complain about live shelling, which to me it's a paradox. This shouldn't be that way. Or someone goes hunting and says, no, you cannot pick up a live animal. True, if you can get an empty shell instead of a living one, you probably should be doing that. Anyway, I don't know if I answered your question. Thank you. Yes.
But if you harvest some for food,
I'm sorry?
some people harvest them for food.
Yes.
And so
Some people harvest them for food, which is, from the human ethics standpoint is okay, I guess. There's a lot of aquaculture going on too. We had aquaculture on Pine Island for a long time on some local species of clam, like the quahog, the southern quahog, also the northern quahog, which are big clams, and the sunray venus. I actually ate sunray venus grown on Pine Island. It's really great. But I think the red tide had a bad effect. They had to close the farms.
Hey, Jose.
Thank you.
Yeah, thanks. All right, thanks, Jose. I just want to say one more thing real quickly, which is for the curious, Sanibel is open, as is Captiva. As of January 2nd, the bridge is open to anybody, no pass required. They're going to start opening beaches back up in February. I think they're starting with restricted access beaches, but then the public beaches will be soon after. About a dozen restaurants are open. There are actually 2 accommodations properties that are open for people familiar with the island. Two of the most established ones, Tween Waters on Captiva and the Island Inn on Sanibel are open. I'm not suggesting you go anywhere else, but they're the Manasada Beach. I'm just saying that if you're interested in a trip to kind of get a look at things and maybe visit the beaches and some trail, and thank you very much, Addie, and the museum, which on February 1st, we're actually going to, even though we've got a lot of rebuilding still ahead of us, we're actually going to reopen in kind of a limited edition way for a couple months until the building really begins. So it'll be free of charge. We'll be open Tuesday through Friday. This Great Hall of Shells I mentioned is going to be open, and we'll have some other aspects of the experience too. But I would say come visit. Yep.
You will have a donation jar.
Why, of course, we'll have a donation jar. Yeah, we'll have that, and of course, there's always the online donation jar. And yeah, thank you. So yeah, thank you guys very much for your attention today and for allowing us to be here. Thank you, Buffy. Yeah.
And we'll see you next week.